Welcome everyone, and thanks for joining our session today. Continuing with our DMC webinar series, today we want to show another point of integration between S4 and DMC. In this case, we will focus on the integration with production planning and schedule. On today's agenda, we will begin with the relevance of an integrated system between production planning and execution. Then we will start with an introduction to SAP production planning and scheduling and the SAP digital manufacturing solution, giving a high-level detail on the solution available. After, we will show you what different scenarios and processes can be implemented between the functionalities. And finally, we will demonstrate you some of the functionalities we presented before within the actual system of the S/4HANA and DMC, going deeper into how the system gets integrated and the different actions that can take place. But before we begin, let me introduce the team that is presenting today's session. Alexander is an SAP Industry 4.0 consultant and focuses on manufacturing and asset management. My name is Sandra. I have more than 15 years of experience in the supply chain, and I'm responsible for our manufacturing team. Both of us are part of our Industry 4.0. And let me give you a few practical terms for this webinar. Everyone will be muted. You can raise your questions in the chat box on the right side of your screen. We will collect all those questions and answer them at the end of our presentation, and then the presentation will be recorded and distributed afterwards. This is the 6th webinar of our Industry 4.0 series, so I want to highlight that there will be more after the summer break, focusing on intelligent asset management and manufacturing, and as well Insights DMC. And don't forget, you can also find the links to our previous webinars on our YouTube channel or within Westernacher website. Before we get started, let us also briefly have a look at who we are in a nutshell. We are an SAP Gold partner with a history of more than 50 years. We have more than 650 consultants globally from Americas, Europe to Asia, and we are 100% employee-owned. We cover the SAP Digital Supply Chain Solution portfolio from planning to manufacturing up to the logistics execution, all integrated into S/4HANA, ERP, and finance. For today's sessions, both of us, part of our Industry 4.0 team, this team focuses on the aspect of asset management and manufacturing with SAP technology, connecting planning and logistics execution, but also integrating machines, so OT and processes, covering a piece of Westernacher portfolio, both from IT and business perspective. So getting back to today's topic, these days manufacturing companies are confronted with changing conditions. They experience an intensifying market saturation and changing customer demands for individualized products at the same cost as mass products. This leads to higher complexity and demand for more flexibility in organization, planning, and manufacturing processes. Companies need to reduce the time to market of new products further and to start the production even earlier. Shorter product life cycles require faster product development and planning of corresponding manufacturing system. The industry is looking for technology advancements to help improve shop floor productivity, growth, and ensure delivering unparalleled customer experience. Integration of forecast planning, process planning and scheduling, shop floor control, and execution seeks to create new efficiencies for the manufacturer that allow the business to save money by controlling and reducing cost. Integrating the different processes is an approach that enables each system to function more effectively, especially in those organizations where production to order is dominant or an increasing number of different parts to be manufactured in lower lot sizes is required. There is a connection between planning and execution, obviously. And while this is obviously dependent on implementing the right software solution with real-time reporting and adjustment capabilities, it is as well important the philosophy to follow a different strategy, more focus on continuous planning. Continuous planning with assistance from network systems, cloud computing, and in-memory technologies is a way to drive value and increase supply chain efficiency, especially in a more diverse, variant-rich supply stream with production and warehousing on a global scale. So additional strategic decisions should be done setting the manufacturing facilities and the operational strategies, such as lot sizes and workflow to couple the customer orders. As the rapidly changing situation that happens in real manufacturing environments involving some aspects like material availability, order due dates, lot sizes, route sheets, lead times, and manufacturing resources, this results in difficulty in carry out the daily plan. Where combining planning and execution into a continuum planning strategy comes into play is creating this bridge between these two systems, planning and execution, whereby each facility will increase its automation, like business processes flows, the agility, like the data alignment between shop floor and top floor, and conducting a specific lot size scenarios, the efficiency, like resource dispatching or reduction cost and buffer capacities, and as well the continuous optimization, like the accumulation of data and all the reporting, allowing to enhance track and trace. All this is crucial to drive production to meet the customer delivery on time in the specified quantities and conditions. So let me explain you a little bit about the S/4HANA manufacturing for planning and scheduling, which is the new name of the S/4HANA PPDS after SAP moved part of the APO solution into S/4HANA. The migration of PPDS to S4 comes with simplifications in interface for master data and transactional data, with an aligned process integration with SAP S/4HANA, and as a result, with DMC2. Manufacturing for planning and scheduling provides many different features to fine-tune your production planning activities, like the sub-daily planning possibilities, advanced planning and schedule features, and the what-if scenarios, and then specific planning features and advanced algorithms to support automotive, mill, or process industries. As well, using the SAP Fury apps, the user experience improves and will stress the simplicity and effectiveness of this S/4HANA solution. Everything helps companies to determine what, when, and where to make or buy, considering equipment and production facilities by executing an MRP and CRP. The goal is to maximize the efficiency of production and reduction of cost to the lowest. The output, which is a finite capacity plan, helps companies to reduce the customer cycle times, simplify planning, minimize shortages, and optimize capacity. And now I leave the floor to Alex, who will explain more about DMC.
Okay, then let's get started with an overview of the Digital Manufacturing Cloud. For those guys who haven't attended any of our webinars, this is, for the others, this will be a bit of a repetition, but I guess it can never hurt to hear things twice. So, as you can clearly see, the elements of production, execution, and insights represent the main parts of the DMC, where the first element of the execution is including the functionalities to perform a seamless production execution, as the name says. And the insights part is basically responsible for data analysis and KPI monitoring. The resource orchestration module, or REO module, on the left-hand side combines the functionalities to dispatch and sequence operations to the different resources on the shop floor. So basically, resources are in the context of the DMC machines or general equipment that is needed for production. So basically the modules of execution, insights, and Rio are the three elements that are distinguishable also through licensing. So I really want to highlight that all three can be integrated as individual modules into your individual landscapes. So whereas the execution license includes the insights functionalities as well as the resource functionalities. However, the DMC incorporates further capabilities that are, of course, worth mentioning, such as the automation functional or all the automation functionalities that you can see at the bottom left of the cloud, which basically enables the implementation of a tight shop floor integration to DMC. Whether that is from machines, from IoT gateways, systems, from Pico, plant connectivity. And this, on the one hand, allows a fast data processing in near real time, and it also enables the implementation of all kinds of automation scenarios. Coming to the right-hand side of the cloud, you can see the manufacturing network, which basically allows you to collaborate with different network partners like customers, suppliers, OEMs, and other service providers. So within this network, you're also able to depict the whole material life cycle over the borders of your companies, basically. So this is, of course, also or can be relevant in terms of when we think of corporate social responsibility or supply chain auditing and so forth. Now, enough of the DMC in general. If you have any questions further on the functionalities on this, please feel free to ask. But now we'll go deeper into the subject of PP and DMC integration. So first, when we look at the MPS on the left-hand side as an integrated part of the ERP system, we can see that it includes all the different functionalities to support an accurate and detailed planning of orders. So this is, of course, for the varying production environments across industry and general companies. You have different planning modules, different modes, and so on. On the bottom, or on the left bottom side, you can see the desired outcomes you want to have of such a planning cycle. So we basically should have a scheduled and optimized production plan where the different work orders and operations are scheduled for the manufacturing floor. These are then released and sent to the MES, or Manufacturing Execution System, which is in this case the DMC. As the DMC has its own short-term planning module with resource orchestration, or RIO, you can alter the respective order planning before doing the final release of the orders to the shop floor. So you can basically adapt the scheduling coming from the MPS module dependent on what is actually happening on the shop floor. Thereafter comes the execution part, where the operators are managing the manufacturing process, and the system sends back all the production status of the different orders to the ERP. So as you can clearly see, it is very important, or a mindful integration of these two modules brings an advantage of data accuracy, traceability, and also an increase in velocity of information exchange. So basically, one could imagine this as like a cascade, and when the planning and scheduling is off at the very start of the cascade, at the very beginning, the execution will be off as well, of course, and that's why it's so important to integrate these two features, or the planning and the execution. Coming to the detailed functionalities of the DMC, we can see that there are basically three different parts that are interesting. So at first we have the RIO again, which I have mentioned before, where you're able to reschedule and dispatch the planned orders coming from the MPS. However, you are also able to use other functionalities of tools, such as monitoring the respective production stages where the different orders are at. Further, you have the possibility to visualize high priority orders, display machine breakdowns and missing labor. But that we have all shown with in a previous webinar. So if you're interested in looking further into this, feel free to go on YouTube or on our website. Coming to manufacturing execution, on release of the respective order, an SFC or batch number is created dependent on what industry you're in, basically. So for those guys who don't know what an SFC or shop floor control number is, it's basically like a batch number, which is a unique identifier for the individual materials being created. So through this, you can find the corresponding material and the information attached to it at every production stage. There are also multiple supporting features, such as data collection features and exception handling. As you can see on the bottom, indicated through the different arrows, these are the status updates, which are basically goods consumption, goods requests, yield confirmations, and so on and so forth. Lastly, when we look at the track and trace functionality, there are mainly two different applications to track the data. This is on the one hand, the product history report and the product genealogy report. The history report is way more detailed in terms of what you have done with your product, and the genealogy report has the ability to see what has happened within the network. So what did our supplier do? What did the OEM do? What did another service provider do? So this can, however, only be realized when all involved are willing to share their information, of course. Within the demonstration, we will also talk a bit about the different supporting functionalities in production execution provided by the DMC. So we are going to go a bit deeper into the topic of how exceptions are going to be handled, as this was also something you have asked within our last webinars that you would like to see. Further, we are going to show the data collection functionality, which has also links to non-conformance management. And lastly, we're going to present the track and trace functionalities and monitors. But first, I'm going to give you a bit of a theoretical background. So starting with the handling of exceptions in the production, this is mainly done by the non-conformance routings. So in the DMC, you have the possibility to graphical design your routings, also your non-conformance routings, where you have the possibility to break out from the standard routing and perform the necessary steps to either repair, scrap, or send the material back to another operation. Thereby, we can trigger non-conformances based on SFC level, and additionally, you can assign certain information or custom information to the respective NC codes that are relevant for further analysis. So we can assign a bunch of different information. The data collection capability allows you to record traceability and ensures production quality by monitoring the adherence of production specification, and also by validating collected data against predefined limits. Data is collected using user-defined data parameters assigned to data collection groups. So you can either perform this data collection automatically or manually, however you wish. Okay, then let's look at the general process we have. First of all, we're going, or a general process that could be. So first of all, we're starting with the MRP, the material requirements planning. Then there's the evaluation of stocks, what is our requirement situation. Thereupon production orders created. We then evaluate and plan the capacity situations. And then going to the DMC, you can see that we either go directly into the resource orchestration, where we can reschedule our operations, or we go directly into the release of the orders within the DMC. Then comes our production execution, where we have different functionalities of track and tracing the material. We can assemble our products, do the data collection, non-conformance handling, and among others. And while we're doing that, we're sending back information back to the ERP system. For example, order consumption, or when the process order is confirmed and finished, and also when the goods receipt is going to be triggered. Okay, we have also provided, or we're providing a story for you, just for you to have a better overview of what we're doing within this system. So we are basically having two systems, as you can see. These are the ones that we have talked about, the ERP MPS, where Lisa, the production planner, is responsible again, and the DMC, where Felix, the production planner, is responsible. So for the business scenario, first of all, we're going to go into the Fiori application of the S/4HANA. Then we're going to monitor the capacity utilization. Then we go to plan different orders within the graphical planning board and release the production order to the DMC, or the shop floor. We're going to receive the order and release it, assemble the components, show you a few functionalities within there. Then we're going to conduct the material testing, where we're going to perform a data collection again. Then we go further into exception handling with non-conformances, and our last operation will be the labeling, where we document some equipment downtime and trigger maintenance alert. So basically, we have three different operations again: the assembly, the testing, and the labeling. Lastly, we will look into the product history and genealogy before we go back to the ERP system and look into what data has been sent back from the DMC to the ERP system. So now I give back to Sandra, who's starting within the MPS, and you will hear from me later on again.
Yeah. So for the sake of the demo, the MRP has already been run. We have already checked the availability, and we have converted the planned orders into process orders. Next step that the users will be doing is checking the monitor capacity to check the availability of, or the utilization of, the different resources. We'll be using the Fiori apps, which I think it's a good and nicer way of checking the capacity of the different resources. It's a new functionality provided by the new S/4HANA PPDS, and here you can see the different resources very easily by colors, the capacity of different ones. So you can check the evaluation horizon for 14 days or a bigger horizon. And as well, you can go into the details of the resource, checking the utilization for each single one, and then split it. So you'll be able to see the different hours utilized by each, by the percentage utilized by different resources, and then schedule it accordingly. As you can see, we have plenty of orders for today. And one of the things that we'll be doing is doing an scheduling using the detailed scheduling planning board that we are having here on the Fiori apps. Okay, but this is an easy way of seeing the utilization of the different resources by colors. If you go for the new Fiori app there for production scheduling, it's pretty similar to the DSPB, the detailed scheduling planning board provided by S4 in APO and in S4, but it's, I think, in my opinion, it's nicer. It has a better user interface. And there you can, as always, it's pretty similar to the Rio application, but with not having the option of doing all the dispatching, obviously. And here you have absolutely all the different functionalities that the detailed scheduling planning board. It's just checking the mode to the scheduling, so by find slot, insert operation, or infinite scheduling, as well the directions, forwards and backwards, if you consider that you have to check by start date or end date. And then on the scheduling, you have the different options to work with the operations and as well the heuristics. And as the DSPB functionality, you can create, delete orders, change quantity, and change the order, the source of supply. This can be configured, obviously. And then what we can see here is that the assembly, which was the resource that we saw on the capacity monitor, it was overloaded. We can see that we have plenty of orders for that resource. What we are going to do is to schedule all of those on a sequence. So we'll be selecting the resource and schedule the orders. In this case, we are using the standard, but you could always have a specific sequence to consider, not only on the requirement state. Just take a while. So you can see now what we are having is just a sequence there of all the different orders with no overloading or with no overloading or overlapping the resource. Then we will be adopting the resource, so we'll be adopting the sequence and the plan of the different resources. And one of the steps that we will be doing later, as we have the schedule done, it's to send this information or one of the orders to the DMC. So basically what we'll be doing is going back to S/4HANA, and here on MD04, you will be picking one of the orders, for example, this one, 656, and what we'll be doing is releasing. By releasing the order, what we are doing is sending that information to DMC. Okay, and now I leave the demo to Alex, who will be explaining you DMC.
Looking into the DMC, we are going to go into, now you can see me again, put me away. We are going now into the manage order application, where we are going to see the order that Sandra has sent to us. It was the, what I forgot the order. 5. Sandra, could you tell me the order
656.
Again? 656. Thank you very much. So the order should be there. I'm going to reload it. Some latency problems right now. No, they're there. 656. And there's the order that Sandra has created with all the planning and detailed scheduling details we have here. So if you click on here, we are able to release our order. Here we have even more detailed data about the respective order, how much quantity we want to produce, or we need, quality done, and so on and so forth. So we're going to release the order. We're going to release just a quantity of 1 because we have the capacity right now only for 1, and we're going to release it with a quantity of 1, first and last SFC at the operation activity assembly. So I'm going to close it again, and now we're going to go into the custom work center POD. So this is basically a POD we have designed ourselves within the POD designer, which is a fairly easy to use application where you can use drag and drop functionalities to just click together your dashboard as a wish, if you have the respective plugins, of course. So if we go on here, we can see that we have different filtering options with work center resource. Also, we can search for the respective SFC, and we're going to search for our material at the operation activity assembly. Here we can see our our respective SFC. So everything seems to be fine. So when we click on this order, we can see that we have a dashboard with different buttons. First of all, different information regarding the other order. Then we have different buttons in place. So on start, you start the order. That is very intuitive. On sign off, you can revert the start again and send your operation or your material in queue again, or your SFC, better said. In completion, you complete the operation. Non-conformances, there you can handle exceptions, which we will see later on. And on actions, you can change the equipment status, or so schedule downtimes and so forth, and you can raise alerts. But that we will also see later on. So we're going to start the operation, and the SFC has been started at the assembly, and as we can see, we have first we have different work instructions in place. So last time I've shown you that this PDF document, so there are basically different files that you can attach to the work instructions. What we have implemented now is a 3D object, which takes a little bit of loading, where you can see basically the 3D visualization of your motherboard in this case. So you can also drop down, and there you have all the different materials that are attached to this specific motherboard. So if I click on this eye, you have seen that this specific thing has disappeared here. So you can really drill down into the specific components of the motherboard and just look around it. There's another functionality. So if you click in here, you can see that this pop-up is going to show up, and where you have, if you have it in place, can display, okay, how is this motherboard going to be assembled with different steps, and you can play them all through, which will be even more intuitive. Now we're going to go to the component list, where we can see the different components that are in place, and we're going to assemble them again. So we have the different inventory, the different components that we're going to add to the motherboard. This we have shown also in a webinar before, but I'm just going to do it for the product history we will look into later on. Now we have assembled everything. We have a green box that says, okay, everything is okay, so we can complete this operation. When we click on complete, the operation is going to go to the testing operation. When we go into, there we have the order right now at the operation activity inspection. Now we have a data collection list assigned to this different certain operation. So there's different data collections that we can perform. So inspection task, we have maintained how many capacitors there are bent. And as you can see, we have min and max values. So when the values I put in here are within these min and max values, everything is okay, and the data is going to be recorded. So, but when it's outside of this limit, a non-conformance is going to be triggered. This is what I'm going to show you right now manually, but when I do this and save it and would, for example, put a number of 5 in here, automatically the non-conformance routing would be triggered. So for you to further understand, this I'm going to save for right now. So for you guys to understand what I'm meaning, or in more detail, I'm going to go deeper into this non-conformances. So when we click on here, you can see at first a bunch of information. So first of all, certain information about the respective SFC, and then we have the NC selection plugin. So here we have the nonconformance groups where different nonconformance codes are assigned to. So this is basically how you can drill down to the specific nonconformance code you want to log. So here you have different nonconformance groups that are all filled with different nonconformance codes. At this nonconformance code, there's a nonconformance routing assigned to it. Which it goes into when we log this specific nonconformance code. So I'm going to log this, and as you can see, it has been assigned to the nonconformance. The nonconformance code misplaced has been assigned to the respective SFC. So I'm going to add it. And now, as this is all a bit complicated, I know, I'm going to show you the visualization of the routing that is assigned to the respective code that I've just added to the SFC. So we have, at first, when we click on that code and assign it, we're going to go into the activity of PR custom, and we have different routings where we can go. So we can go to stick resistors, so basically back to the assembly. We can scrap the material, we can go into repair, or we can go into labeling, which is our last operation. So I'm going to add this NC code, and now you can see that it's going to be processed as PMR custom, as you have seen within the routing. So now you can see that the material or SFC is at the PMR custom, and we also have this repair operation in place. So now we're at this specific operation, and when I click on start, it's going to be started. I have different work operations again assigned to it. Within this operation, different actions I can do, and so forth. So when I complete it, I get the different things I can select, or selections that I've shown you within the routing. So within here, we're going to do the repair. We're going to click on repeat, and the operation is going to be at the activity repair. Okay, now you can see the status icon is done. We're all finished, and we're going to click on start at the repair operation, and we're going to complete it however the completion is going to take place. So as we are a bit in a time pressure, I'm going to hurry up a bit. Now, when we go into the work center print or in the operation labeling, we can see that our operation is there again. And what I wanted to show you within this operation is that on the button actions, you can change the equipment status. So we have the respective resource print, we have the status unknown in this case. But for example, the operator could schedule an unscheduled downtime and assign a certain reason code to it. So in this case, that would be connection lost OT, and we would say sensor is not functional, and we could change it. And this reason code is really important for analytical purposes. So also, I mean, when we have like a maintenance task, when the machine is down, we can raise an alert to the maintenance request, and notify certain users and send a certain message to it, so that the maintenance guy is going to be alerted. So we're going to start and complete this as well. And now the operations have all been conducted. Now, the last thing I wanted to show you real quickly is the history of the product, because everything that I just have done has been wasn't it 656, has been tracked and traced. So as you can see here, we have all the different all the different operations. So SFC release, start, we have all the different operations listed into a very nice list. So we have the different assembly points, material circuit board small has been attached to the component. We have the data collection. We have the red indication of that we had defect logged, and so on and so forth. We had the data collections. We see the different non-conformances, and yeah. So basically within this tool, we have everything, all the history that we wanted to see, or that we have conducted, the operations that we have conducted. We can look into the work instructions, where we can see when an operator has looked into the different work instructions, and so on and so forth. So you can really see everything that has been done within the assembly of the respective product. And yeah, this is basically what I wanted to show you guys. So as we have a bit of a time pressure, I'm not going to go into the ERP system right now, but what has happened when I finished the operation is that a message has been sent to the ERP system where with the yield confirmation, basically, so that the material has been produced. Okay. This was on it. Okay. Now coming back to our presentation. Thank you very much. I hope you could. It was understandable what we were trying to tell you, and you learned a lot. And now it's time for questions, basically. Yeah. So I guess we're going to answer one question, and all the other questions that you have, we're going to answer after this webinar and come to you personally. So when we look at the question, so Sandra, basically here's a question for you, I guess. When should we use the embedded solution of PPDS? Shouldn't it be enough? Shouldn't it be enough for the MRP? Shouldn't it be enough with the MRP live? Sorry, now I have it.
Basically, you should use the embedded solution when there is a requirement of having a detailed scheduling with constraints, or really a complex production process. So, for example, there are some process flows within the process industry which are really complex, moving from one resource to another, having intermediates there in between. Then the recommendation is to use the embedded solution of PPDS. It's true that the MRP Live has improved functionalities compared to its previous version or solution, but it doesn't plan considering capacity. So whenever there is a requirement of having a solution to consider the capacity is where the embedded solution of PPDS should take place. Besides the PPDS solution or the embedded solution, it's having more heuristics available, like the shelf life or the continuous input-output. So what we would say is that the solution, the embedded solution, will bring more features to fine-tune your production planning. I hope it answers there.
Okay, yeah, I guess that should suffice. Okay, then I guess we'll close the webinar. Thank you very much for your attendance. You guys learned something. If you have any other questions regarding DMC or PPDS or MPS, feel free to ask us. We're very excited about the topic, and yeah, have a nice further day. Thank you very much.